Many people have heard of FPGAs or field programmable gate arrays, but not everyone truly understands why they are so important, especially when compared to ASICs, which are application-specific integrated circuits. So why FPGA? Today, I will walk you through the key advantages of FPGAs and why they are such a critical tool in the world of electronics. By the end of this presentation, you will see how FPGAs shine in areas like flexibility, cost, and time to market. Let's dive in and explore what sets it apart and why they are often preferred for testing, prototyping, and development. The first, and perhaps one of the most significant advantages of FPGA is their recoverability. What does this mean? Well, FPGA can be reprogrammed multiple times to test different designs or implement iterative changes during development. Imagine you are prototyping a product. You can tweak and modify your design over and over without having to create new hardware each time. ASICs, on the other hand, are fixed designs. Once fabricated, they cannot be changed, meaning that if you need updates or corrections, you are looking at creating an entire new chip. This ability to adapt and experiment without additional hardware is what makes FPGA a standout choice, especially in early development stages. The configurability is a huge advantage and leads us direct to our next point. Time to market. Time to market is crucial in today's fast-paced industries, where getting your product out quickly can mean the difference between success and failures. FPGAs shine in this area because they bypass the lengthy fabrication process that ASICs require. Developing an ASIC often takes months, if not longer, due to complex fabrication steps. In contrast, FPGAs allow developers to program and test their design almost instantaneously. This shorter timeline is especially important for business operating in competitive environments, where ASIC might eventually offer efficiency for mass production. They simply cannot compete with the rapid turnaround that FPGA provides. Now, you might be thinking, how about the cost? Let's explore in the next slide. Another big reason to choose FPGA is their low initial cost. Developing an ASIC is expensive. There are high upfront costs for design, tooling, and fabrications. This investment only makes sense for large-scale production, where this cost can be amortized over millions of units. On the other hand, FPGAs are much more economic for low to medium production volume, or for projects with involving design requirements. If you are working on an application that doesn't justify the significant cost of an ASIC, FPGAs provide a flexible and cost-effective alternative. Their low initial cost makes them a smart choice for startup or business exploring innovative design without committing to the risk of full-scale production. Speaking of flexibility, let's talk about how FPGA handle change on the fly. Flexibility is where FPGA really shine. With an FPGA, you can make on-the-fly modification to your design, whether it's testing a new feature, fine-tuning performance, or fixing a bug. All of this can be done without requiring new hardware. ASICs, however, lack this flexibility. Making updates to an ASIC involves a lengthy process of redesign, mask changes, and additional tooling, which is not only time-consuming but also costly. This makes FPGAs an ideal choice for dynamic development process where change is inevitable. Whether you are prototyping a new product or troubleshooting issues during testing, this flexibility provides an unmatched advantage. Now, let's move on to discuss another key strength of FPGAs, their parallel processing capability. FPGA excels at parallel processing, which is the ability to handle multiple tasks simultaneously. This makes them particularly valuable in applications that require high-speed computation, like data centers, real-time processing, or testing complex algorithms. Because FPGA can be programmed to perform several operations in parallel, they are far more efficient than traditional sequential processing systems. While ASIC can also be designed for parallel processing, they lack the flexibility of FPGAs to adjust or scale this capability to meet changing requirements. This makes FPGA a superior choice when it comes to tasks that demand efficiency and speed. Now that they are covered the key advantage of FPGAs, let's take a look at where they are commonly used. FPGAs are incredibly versatile and find applications across a wide range of industries. In telecommunications and networking, they are used for high-speed data processing. In data center and high-performance computing, FPGA accelerate workloads like machine learning and AI. Aerospace and defense industrial rely on FPGA for their reliability and adaptability in mission-critical systems. In automotive industry, FPGA enable advanced driver assistance systems to another vehicle technology. They are also widely used in the industrial applications such as automation and control, as well as in medical imaging, where high-speed processing is essential. These diverse applications highlight just how adaptable FPGAs are for solving complex, high-performance problems. Finally, let's summarize why FPGA continue to be a preferable choice. Here are the summarized images showing you why FPGA are so powerful and widely used. First, they offer recoverability, making them ideal for iterative testing and prototyping. Second, they enable a shorter time to market, making business quickly deploy new designs. Third, they provide cost efficiency with low initial cost for projects that don't justify the expense of an ASIC. Fourth, their flexibility allows the on-the-fly updates and changes, which are invaluable in dynamic environments. Finally, the parallel processing capability made them highly efficient for high-performance applications. Together, these advantages make FPGA a preferred choice for testing, prototyping, and development, particularly in industries where speed, flexibility, and cost are critical. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.